Okay, hello everybody. Today we are going to do 5.01 to 5.03 Heat and Kinetic Theory. Kinetic theory is the theory that everything is made of tiny particles called atoms. They are constantly in motion and attract each other when close. That's what an atom looks like. I'm sure you know. An atom is made of electrons, protons, and neutrons. Neutrons and protons form the nucleon and they are in the middle. Electrons are on the outside and they circle around the nucleon. Okay. 5.1 Moving particles. So as you know, there is three types of states of matter. There is solid, liquid, and gas. And the gas, the particles inside the solid are... Wait, there is gas? I mean the particles inside the solid is rigid. And it has a fixed shape and fixed volume. Cannot be squashed. So the solid, it cannot move anywhere. It can only vibrate in place. The liquid is not rigid, no fixed shape, but it has a fixed volume. Cannot be squashed. As you can see, it's not rigid. It can move around. It doesn't have a fixed shape. But it has a fixed volume and cannot be squashed. This is because even though it doesn't have as much attraction as the solid, there is still a tiny bit of attraction causing it to have a fixed volume. The gas is not rigid, no fixed shape, and no fixed volume, and can be squashed. That means it can be compressed. This is because there is virtually no attraction between each molecule, and they're basically they're just kind of individual, you know. They're not really part of the group. All right, let's move on. Brownian motion. Brownian motion is the random zigzag motion of a particle caused by random collisions. That's what Brownian motion looks like down there. So as you can see, this big gray one moves here and boom, it gets bumped. And over here, boom, it gets bumped. It gets bumped everywhere. It gets bumped, and then it gets bumped by random molecules, and that's why it's zigzagging throughout. It was discovered by this one guy named Brownian. Oh wait, no, I think his name is like Dr. Brown. I don't remember, but it's like Brown something. So that guy, he like looked through a telescope and he put a pollen molecule. He put pollen and he can see that it was like vibrating. But then he was like, what the hell is that thing vibrating? And so he looked even closer, and it turns out that like the air particles from the air is bumping it around and colliding with it. Alright. Energy of molecules. Atoms have kinetic energy and potential energy. The kinetic energy and potential energy of an atom is called internal energy. When hot material touches a cold one, the internal energy transferred is called heat. Thermal energy is often used for heat and internal energy. That's a lot to take in, but stay with me. Okay, look. This thing, A, it's hot. B, it's cold. And when they touch, it transfers heat, and then it becomes the same temperature throughout. It transfers heat. It's as easy as that. The internal temperature is just the kinetic energy plus the potential energy. Don't bother about the potential energy yet. Just think about the kinetic energy. The kinetic energy here is high, kinetic energy here is low, and the kinetic energy here is high and low, and kinetic energy here is the same. It's because the kinetic energy here has been transferred over here. The transfer is called heat. And so when it's transferred over here, boom, bada bing, bada boom, it's the same temperature. But what is temperature? An object with the same temperature has the same kinetic energy per particle. This means that the speed of a particle vibrating in the same two materials of the same temperature. So what I'm trying to say is that this one is vibrating more than this one, and then over here is vibrating. This one, A, is vibrating the same as B, purple one. Now why? Is because they have the same temperature. If they have the same temperature, that means they have the same kinetic energy. That's what it means. Celsius scale. It's used for measuring how hot something is. The numbers were based on water. At 0 Celsius, water freezes at 100. At 0 Celsius, water freezes, and at 100 it boils. So as you can see, freezing point water 0, boiling point water 100, human body temperature 37. It's kind of random 37, right? It's because it's based on water. But what you might not know is that the human body is made of 70% water. That's why we based it off water, because water is 70% us. Okay, Kelvin scale measures temperature as well, but it starts at the point 0, representing absolute zero. Absolute zero means if a particle is vibrating, it's always vibrating, right? But what if, imagine it stopped vibrating? Then what is the kinetic energy in there? It's called absolute zero. But absolute zero is only hypothetical. That means that it's not really, it doesn't exist and will never exist, because, well, at least we haven't found it yet, because absolute zero is almost impossible, because there is too much energy around any particle for it to stop vibrating instantly. And if it did stop vibrating, probably, I don't know, cause a black hole or something. I really don't know. Okay. It's often used for scientific work. So if Celsius is used for like normal stuff, like, I want to set my aircon at like 2 degrees Celsius. I don't know why would you do that. But yeah, in scientific work, they use Kelvin because they're fancy. If you want to convert Celsius to Kelvin, all you have to do is add 273. That's right. So if you see Celsius is 0, and then you add 273, bada bing bada boom. 273 is the freezing point of water in Kelvin. And so that means that if you want to convert from Kelvin into Celsius, all you have to do is minus 273. So Kelvin, the absolute zero is 0. So if you minus 273, it becomes negative 273. So negative 273 is absolute zero in Celsius. Okay, there you go. K equals to Celsius plus 273.15. Just ignore the 15 because screw that. Thermometers. We use thermometers to measure Celsius. And also Fahrenheit, but nobody uses that. There are multiple types, but we'll be looking at glass bulb thermometers for now. So as you can see, inside there's a bulb, there's a scale there's narrow tube glass, and inside there's liquid. It's mercury or alcohol. It can be either. Yeah, we'll be explaining more into that. Next, different glass bulb thermometers. As you saw before, the liquid could be mercury or alcohol. This is because mercury freezes at negative 39, while alcohol freezes at negative 118. Mercury boils at 500 plus, and alcohol boils way lower than that. So if you want to measure cold temperatures, use alcohol thermometers, and if you want to measure hot temperatures, use a mercury thermometer. So you can see this is the alcohol thermometer. They add food coloring into the alcohol so it becomes red. This is the mercury one. It's very thin. You'll see why in the next slide. So mercury freezes very low at very high temperatures, and alcohol freezes at very low temperatures. So that means that we could measure low temperatures with alcohol, but we can't with mercury because it will just freeze. And we can't measure high temperatures with alcohol because it will just boil. But we can use mercury because it won't boil. Alright, next. Sensitivity. Some thermometers need to be more precise than others, so they need to measure the small changes in temperature. How do they do this? They make the tube narrower. So if you make the tube thinner, it will have less space, so it will travel upwards more when it expands. As you can see, this alcohol, it has a big tube here and a small tube here. It expands here like okay, that's fine. But if you, in the small tube, when in the same temperature, when it expands even more. So that means that you could measure more expansion. So if it changes by like half a degree, you can see that change here, but you can barely see it here. You see what I'm trying to say? Like right here, there's the alcohol, and there's the mercury. Mercury doesn't expand as much as alcohol, and yeah, alcohol expands much more, so the tube can be bigger, and mercury, the tube has to be narrower so that we can see and measure the small changes in expansion. Response time. Some thermometers take a long time to expand and show a new temperature, while others are quick. Why? It's because some thermometers have thick glass, so it takes longer for heat to reach liquid, and because some have bigger bulbs and that take longer to heat up. So if you look at this, both have the same bulb size, but just imagine that this one was smaller. Okay? Just imagine. So if this one is bigger, right? This one is bigger, so it takes heat way longer to like heat up the thing. And also, imagine this one has thick glass and this one has thin glass. So it has to travel through all of that glass, and then after it reaches the glass, it has to travel all through that liquid, and then finally it can heat up. Over here, it has to barely travel through glass, and then once it travels through there, it already reaches the liquid. So it's boom, it's like immediately. See, it's already expanded so quickly, and this one so little. Next, linearity. Although mercury and alcohol thermometers have to agree at fixed points, they don't at other temperatures, because their expansion becomes non-linear compared with others. However, within 0 to 100, this disagreement is very small. Well, what I'm trying to say here is that so alcohol and mercury, it expands differently at different temperatures. That's why it's like this, right? It's very linear. If you look at it, it's quite similar within 0 to 100. But however, if you go above 100, then mercury will probably expand less or expand more, and alcohol will probably boil, and it's basically it won't expand the same. Alright, that's about it. Thank you for watching and listening. So, sorry, it's really bad tau. Like, can you give me a break? I just came back from Penang, like, please. Like, why?